right, so I'm going to go ahead and start with a very brief definition. Okay, like short. So piecewise. Oh, today is the 18th. Okay, piecewise. Is a function defined by more than one expression and corresponding domain. Okay, so I'm going to give you the format, right? What does it look like? What's the notation? Okay, and the expression goes here, comma, the corresponding domain here. And it just says more than one, which means you just list as many as you have in the problem, but it's more than one. If it were only one, it would be a linear equation that you graphed last class. This time, it's going to be, and this is piecewise, but we are doing linear piecewise, which means it will be more than one linear expression and corresponding domain. All right, we're going to do it by examples. Okay. Right. We'll just graph it right up here. So we're going to graph. F of x equals, so there's my function notation, and it's going to have two rows, right, two high, and we'll do x plus 6. Notice that that's an expression. It's just x plus 6, comma, x less than or equal to 1. So that means that the expression is x plus 6 and the domain is x less than or equal to 1. The second expression is minus 1/2 x minus 3, comma, x more than 1. So I'm looking at this. I have two linear pieces. And in order to graph this, it's a little bit different. I can't just graph both of these lines. I have to have the correct domain. And so I'm going to start with a table of values over here. Because when you graph piecewise, your endpoints must be accurate. And so we have to plot a few points. In this particular case, the only endpoints I see are at x equals 1, right? That's where the domain is starting and stopping. And so I'm going to put a little dot, 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 lined up. See that dot, dot, dot right in between the two pieces? That's to help me visualize where in the table that the two pieces are occurring. And I'm going to put a 1 here. And I'm going to plug it in. I'm going to find a point. Now, x equals 1 is included in the top row domain. Plug it in here. 1 plus 6. 7. Now, I want to make a little note to myself. An included point is a closed point. I'm just going to put a little closed dot next to that point. Now, how do you graph a line? Point, slope, 2 points. It's kind of up to you. I'm going to just plot a second point. I'm going to plug in 0. 0, notice that I put 0 above the dotted line. That's because 0 is included in the top row domain. 0 is less than or equal to 1. It's included, so that's where I'm going to find the corresponding y-coordinate. 0 plus 6. Okay, moving down. Second row. The endpoint is x equals 1. Yes, 1 showed up twice. 1 shows up twice in your table here. Okay, plug in 1. Minus 1 times 1 minus 3. Just okay. Decimal fraction doesn't actually matter as long as you're not rounding your numbers. Okay, so minus 3.5. But I'm looking at it, and the corresponding domain says that 1 is not included. How do you say something is not included on a graph? Yes, open dot. That endpoint will be open. I still need to know where it is, but it's gonna be open. Okay, I'm gonna plot another point because that one's a fraction. I'd like to plot integer coordinates, so I'm gonna plug in maybe 2 so that the fraction reduces nicely. Notice that 2 is included in the second row domain. Okay, right, this is scratch work, right? My yellow piece of paper here. This is just me trying not to mess up my multiplication. Okay, let's put our dots on the graph. 0, 6. 1, 7. Connect. But keep the domain accurate. Keep in mind this 1 point, and I'm just going to label 1, 7 because I want to know that that's the end point. And I'm going to go this way. Does the line, segment, or ray, because it has an arrow, that I just drew match x plus 6? Yeah, that's a y-intercept of 6 and a positive 1 slope. And the endpoint is at x equals 1 included. Yes, that's a piece of the graph. That is the first piece. The second piece, okay, 1, negative 3.5. Just do your best. If it's not an integer coordinate, just try to get it between the right 2 points. Okay. Not very easy to count slope from there, which is why I plotted another point. 2, negative 4. Okay, that's a negative 1/2 slope. I feel like I could count my slope to help me draw the rest of the line. Connect. And the only points that I really need labeled, the endpoints. And so I'm just going to write the endpoint down here. 1, negative 7 over 2. You need to know the endpoints. The rest of the points are there to help you actually draw the graph. All right. Negative 1/2 x minus 3. Now I'm just going to look at it and I'm going to see if it makes sense. Does this graph, this piece, have a negative 1/2 slope? Yes. Does it have a y-intercept? No. This piece does not actually cross the y-axis, which is why you can't always rely on mx plus b in order to graph it. There is no y-intercept. Okay. Are my endpoints correct? Included? Not included? Yes. You have to show accurate endpoints. Wherever they are, you have to have endpoints on your segments in the correct spot, labeled so that I can see where they are. Okay, number 2. Graph. 3 pieces. Okay. How many endpoints? 5 endpoints, right? Every one of these x values is going to give you an endpoint that you have to have plotted accurately. So I'm just going to make my little table. Three pieces. Give myself a little extra room here. Okay, -2, -2, 3, 3, 6, right? Those values, -2, they show up in more than one spot. Just notice one's included, one is not. One is not, one is not. That just means they're open points. I still need to see where they are. All right, so closed, open, 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 open. That is just for me to recognize what I'm doing so that you understand how I'm making the decision of open and closed points. Okay? See if you can fill in that table. Yeah.
How do you tell if it's open?
Okay, good question. So you see here, x is -2, x is the domain. This is the domain right here. Is -2 included? Yes, included. Is -2 included here? No. It's still an endpoint, right? But it is not actually included. It's an open circle. But the point is still gonna be there. Okay. Negative, negative, plus. So we get Can we make this a -5, guys? Sorry. Sorry. Make it a -5. It fits better on your graph, I think. There you go. Okay. Yeah, make it -5. Okay. There's no x value. There's no input. Yeah, just -4. Oh, it's a horizontal line with a slope of 0, you mean? Yeah, horizontal line with a slope of 0. Okay. Ooh, the next one. Okay. 3. A lot of this evaluating you could probably do in your head, right? A little bit of scratch work. I got a lot of points in the same place. It's okay. Okay, put your endpoints on the graph. Well, I only have 1 point, but I need to actually draw that line. You can graph lines from any point. This one has a -1 slope. So I'm just going to go and count a -1 slope from the endpoint. From the endpoint, I will count a -1 slope. Right? It's kind of, you also got to look at big picture. Does the first piece have a -1 slope? Yes. Is your endpoint in the right place? Yes, that's it. That's the equation of the line. That's the graph of the line. Does this first piece have a y-intercept? No. That's why -5 is not necessarily a useful number for you, because you might not use it depending upon where the graph is. Okay, next part. Open, open, connect. Guys, these are lines. 2 points connect a line. Okay. Next. Okay, 3, -4, open. It's okay if 2 open points end up on top of each other. It's all right. 6, 3, 4, 5, 6, 2. Now, I can tell by looking at this that the slope is 2. I'm just counting slope to help me draw my line a little bit straighter. Three pieces. Okay. Follow-up question. What's the domain? What's the range? Right? Characteristics don't disappear just because we have a new graph. Question or answer? Question. Yes.
You have to, like, label your points.
Oh, yeah. Yeah, okay. So here's the deal. I don't actually need you to label them twice. My endpoints are clearly shown in the table. That would be enough information, because the more pieces you draw, the messier your graph could get. So they either need to be labeled nicely on the graph or clearly in the table next to it. But somewhere I need to see the endpoints and the coordinates that correspond. Yeah, so I'm going to leave mine in the table because that's 5 points. I don't really need to write them on top of it. Okay, think about your domain and range. How would you define them? Let's do interval notation. It's not continuous because I have to pick my pencil up to draw it. Any volunteer? Any suggestions? Yes, Laura?
Open bracket, -infinity.
Okay, yes, agreed.
To -2, close bracket. And then u.
Mm-hmm.
And open bracket, -2.
Not necessarily. Not necessarily. You're on the right track, but not necessarily. I'm actually going to do this. She's almost there. How are you going to finish that? -2 is not the right number.
6.
6 is the right number here. We're missing something in between.
After -infinity,
3. Okay, look at the overlap. Look at the overlap. Yeah, I do pick my pencil up at -2, but you don't exclude and then include. it's one or the other. It cannot be both. This is included. -2 is included in the domain. But 3 is not. There's no overlap at 3. So 3 is where the domain is discontinuous. Even though I do pick my pencil up twice, this is the corresponding domain. Okay, what about range? Yeah?
It's included -4 to infinity.
Yes. This one, okay, I do see those 2 open endpoints. However, look at all those -4 values between them. Included, even though there's a gap, it's included. Even though there's an open circle, there's an arrow. You're including from -4 to positive infinity. All right, last one, try it on your own. 3 pieces. Now you do as much or as little work that you need to in order to get the graph on there. Okay? Because what I have shown you is not necessarily the fastest way. It's just a way. Okay? It's just a way to do it. It's not necessarily the fastest way yet. Now you use all that information that you know about how to graph lines, and can you speed this up a little bit? All right, so I look at the first one, I'm like, oh, point slope form. That is point slope form, which is right 1 up 2. I'm going to use a pencil for a second. Right 1 up 2. Right 1 up 2. I'm not actually graphing it yet, guys. I'm just trying to see what I know. With a +3 slope. Did I just graph a line accurate to this thing here? I think so, but I need to get the appropriate domain. Look at where the endpoints are. Well, this endpoint actually matches -3, okay? And 0. This is it. That's the only piece of that line I need. Okay, was that maybe faster than plugging in points? Right, but you have to know where to look to put your line. You don't want to do a lot of erasing, guys. It gets really messy. But you can. I didn't do a lot of erasing. I kind of just counted and put the points where I needed them to go. I still need to figure out, well, this point, pretty easy. It's at a 0, -1. This point, 3, -10. Because I counted my slope over to get the coordinates. You don't have to plug in, guys, but it is going to work if you do it. Okay? Oh, I know what -2x looks like. That's a negative slope line through the origin because the y-intercept is 0. Looks like this. Now, I'm pretty certain that I can get this one in the right place. All the way up to the x-coordinate of 4. Filled in endpoints. Connect the dots. This is why we review equations of lines first, because you don't have to plot points, but they do need to be accurate. And so this one is 0, 0. And this one is 4, -8. Oh, okay. 3/5 x minus 1. -1 is down here. With a positive 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. Okay, so this one's hard because those points don't really correspond with where I need that line to be. But that's what it's going to look like. I need this to start at the x-coordinate of 4. So I'm just sort of going to, okay, I extended my line, but I'm going to shrink it back down to where it needs to be. Here. This is the integer coordinate. This is the integer coordinate. It's a little tricky because that endpoint is not an integer, but that point right past it is, which I figured out by counting. Now, you still have to label that point. So that point is 4. Okay, we can do it. 4 times 4 minus 1. So that's 12 over 5 minus 1, which is 7 over 5. You still have to label it. Doesn't mean you actually have to plot it, right? I got it in the right place. More than 1, less than 2. Good. Okay. What I just did was slightly different than plug and chug. You should be able to get past the plug and chug point after you practice and you know where you want to put the lines. All right. What goes in each of those blanks?
0.
Yes, but why?
Oh, because there's a closed circle at 0.
Because there's a closed circle. When I say evaluate, I mean which points are included, not open points. I mean filled in dots. Where are they? My filled in dot is down here. Okay? When I ask for evaluating, I am asking for the filled in dots, not where all the endpoints are.
You're supposed to write
Go. Okay. I have 2 pieces. I'm just going to color code because I like to. I have a yellow and a green piece. Now, I have tried to label the coordinates so that you can read them. But let's go ahead and write down the coordinates of the endpoints that you can see. I'm going to do mine in a table here, just because I don't want to write on top of the graph because I don't want to make it messy. I'm just going to label the coordinates that I can see. Well, I see 0, 0. And I see 1, 2, 3, -3. Dot, dot, dot. Right? Because then I get the green piece. And all I'm doing is I'm looking for any of the integer coordinates that I can read off of the graph. I tried to give you dark circles where those points are. 1, 2, 3, -1. Okay? 1, 2, 3, 4, 5, 6, 0. Okay. Just taking the information off the graph. What other information can you take off of the graph if I'm trying to write the equation of the yellow and the green piece? Okay, open and closed. That is important. So let's go closed. Let's go open. That endpoint is open. What other information can you take off the graph? You're trying to write an equation. What do you need to write the equation of a line? Hold on. Slope. Can you see slope? Yes. Okay, so maybe write down what the slope is of each of those pieces. Careful. Get your signs right. It's really tricky when you're only looking at half of a line. Don't look at the arrows. Don't look at the arrows. Look at the slope. Is it rising or falling? It's falling. That means that the slope is -1. Notice that this is the yellow portion, right? This is the yellow portion up there. What is the slope of my green portion? 1/3. Nice. What might you do if you can't actually count slope? Actually do the formula. Okay. Here is my equation. Now, I'm going to do a little bit of scratch work here. Okay. Yellow. Write the equation of the yellow line. Y equals mx plus b. Why would I choose mx plus b? Do you have the y-intercept of the yellow line? Oh, then use it. Then use it. Okay, so yellow is y equals -1x. Done. That's why you review writing equations of lines. I should not have to tell you what format to use, right? I'm telling you now, but you should be able to pick out effectively in your homework. Okay? Green. Do you have the y-intercept of the green one?
No.
Then you cannot use mx plus b. You can use point slope form. You can, and that's up to you. Somebody said I can find the intercept. Go for it. But you make sure you know what you want to do with that information. Okay. Y minus y1 slope x minus x1. Now I chose 6 and 0 because neither one is negative. It's personal preference. Okay. You do, however, need to write this in y equals format. And I noticed that distributing a 1/3 would be very easy and simplify to -2. So I'm going to do it. It's not necessary, but it did divide evenly, so I did. Okay, let's put it together. F of x equals, I have 2 rows, yellow, green. I prefer to just go in order, left to right, right? Start with the domain, left to right. -x with the domain. This is why we go slow with graphing. Now you should be able to pick out the domain that corresponds to the yellow highlighted portion. Anyone want to tell me what the domain is to the yellow? Yeah? Yes, I'm going to write it like this as an inequality. So when you write it in the piecewise equation format, you write the inequality, not the interval. They do mean the same thing though, but we'll do the inequality instead when you do this format. Okay, green. Notice that I'm not rewriting the y equals, I'm just writing the expression part on the other side. Okay. Domain of the green part. Yes. Yeah, x greater than 3. That's it, guys. Okay. That's it, done. Write the equation of the piecewise graph. Each piece separately. Put them together with the correct domain. That's why the first part is 28 minutes and the second part is 12 minutes, because now you have more understanding. Okay, let's try the second one. Notice that the units, look at the units on your graph. I rescaled it. Okay? So make sure you're looking closely at the scale. One, two, three. Okay. Oh, this one's a little tricky. 1, 2.5. Yeah, that's a 2.5. Should you leave room to write another point? Yeah, I might. Because that point was a decimal. I might look for an integer set of coordinates to work with. Hopefully you can find one. So I'm just scanning my graph, right? The green segment, oh, I see this point right here. That's an integer coordinate. Does that work? I can kind of count my slope a little bit. Yeah, okay, so I'm going to add something that's not an endpoint because I'm scanning for points that are easy to use. Your choice, guys. Pick a point you can use. 2, 1. Now I've got the endpoint marked, okay? Because I might need to know where that is. 1, 2, 3, 4, -2. Okay, so I've got my points marked. Now you can write the equation. Okay, so I start here and I'm scanning the green segment for anything that appears to be integer coordinates. And so what I noticed is I can count a rise of 3 and over 2, and that actually works the whole way. And so those other points are points on the line. And so I'm just scanning for any coordinates that are also integers. And so this one, 2, 1, is another point that you can read off the graph. Just because it's not an endpoint doesn't mean you can't use it. Okay, so I'm just looking at my graph. The yellow portion gets a negative slope. Rise 5, yeah, 5 over 4. All right, -5/4 slope, green, okay, green. I guess it doesn't matter. I've got plenty of room here, I think. Okay, green is a negative. Okay, count between integers. 1, 2, 3, 1, 2. -3 over 2. Count between integers. You don't have to count between endpoints. Count between integers. How else do you want to count slope? Because I don't want to count with fractions. Okay, put it together. Ooh. Okay, yellow. Which format you're going to use for yellow?
Point slope.
Yes, point slope. Thank you. I'm not going to use mx plus b because I don't know what the b value is, but it is certainly not easy to read off the graph. Means you cannot use it. It's not there. It's like more than -1/2, but less than -1. That's not specific enough. So you have to use point slope. Okay, now you're going to have to do a negative here. Y minus y1. Slope. X minus x1. You do have to put this in y equals format. You don't necessarily have to do mx plus b, but it does need to be y equals. Now, for good measure and for practice right now, I am going to add up my fractions for practice. Right? I distributed and then I subtracted my 2. Okay. 8. Yeah, that looks about right. It should match your graph, guys. This is also a check on your graph. Does it look like your y-intercept is -3/4? It does. This is a 5. Okay, so there's my yellow. Now I gotta do green, which is point slope form also, because you don't have the y-intercept, so you have to use it. Y minus, okay, I'm going to highlight the point that I'm choosing to use, which was that one in the middle of the graph, because they're both positive, and neither of them are fractions. Still a point on the line. Okay, y minus y1. Slope. X minus x1. Oh, that's not so bad. I can do this. Plus 3. Okay. Yeah, could I have tried counting that out to find the y-intercept? Sure, but you need to know exactly what you want to do with the numbers when you get them. I'm not a piecewise equation yet, guys. That was just like algebra 1 work. Write the equation of a line. Now put it in the piecewise format. I'm going to call this graph g of x because I can. You name it whatever you want, okay? And 2 rows. I'm trying not to take up too much vertical space here. Maybe I should have taken up a little more. I can do it. Okay, so minus 5/4 x. Domain 1, 2, -3, not include 1. Okay. Minus 3/2x plus 4. Not include. 2, 3, 4. Include. There's your piecewise definition. Oh, okay. Oh yeah, guys, that's 3 colors. Notice how the slope changes. That makes it a new line. Even though it's continuous graph, there are 3 lines here. 2 rays and a segment. Okay. You do as much or as little work that you need to. in order to write the equation. Call this h of x. Okay. All right, you have 4 minutes, guys. This is your last example. Good job on your notes. Your homework is worksheet 3 in your packet. All right, this was brand new material, which is why it took so long to go over. I don't know. I'll post it online. I don't know.
Because we still need to do
Well, you're not going to do 1-4. Okay. Domain. Oh, there's something you should notice here. Which ones are open? Which ones are closed? Oh, they're not all closed. This is a function, guys. 1x. You may not repeat x's, which means if I'm going to include -2 on the yellow line, I need to exclude it on the green line. You cannot repeat x's. This is a function. 1x. 1x only. Okay. Oh, there you go. That's kind of in the wrong order, but I'll redo it. Okay, so x greater than 2. Notice, okay, so I defined my endpoints. So when I'm looking at this graph, I'm assuming that the yellow endpoint is open, and then this one is closed, and that this one is closed, and that the pink one is open. That's what I'm assuming. But you can only have one open and one closed, not both closed. Does it matter if you switch them? No, because they're in the same place. So it wouldn't matter because all of those endpoints are actually equal, but you can only include it once. This, I'm just writing down what I decided about the points so that you can tell why I chose closed and open. Oh, green is easy. I can do this. +1 slope with a +2 intercept. Got it. Next, 2/3. Right? I don't always show you the fastest way first, but now I'm just trying to look at the line to see if I can come up with the equation. No, not really. Okay, so pink is going to take a little bit of work. 2/4 with a slope of 2/3. Okay, I started to do pink and I realized I just didn't have enough information. Y minus y1. 2/3. 2/3 x minus 4/3 plus 12/3 8/3. Review adding fractions. Okay, yellow. Can I do yellow? Oh, I can do yellow. I can do this. I think it would be a -4 minus 2x because I very clearly figured out what that intercept would be so that I could use it. That's okay, guys. That's okay. See you later.